Hello friends, in previous lecture we have seen errors in instrument. We have gone through random error, systematic error, instrumentation error, instrumental error and how to eliminate error. And in today's lecture we are going to see current measure instrument and also we are going to understand what is PMMC instrument. So in current measuring instrument, first we will see what is current measuring instrument. The name itself shows that current measuring instrument is nothing but a device used to measure the flow of electric current in the circuit. So one common and important type of current measuring instrument is PMMC instrument. Now going to very basic, what is current? The flow of charge. So current measuring instrument is a device used to measure the electric current, which is the flow of electric charge in circuit. A current measuring instrument is a device used to measure the magnitude of electric current flowing through a circuit. One widely used instrument for the measuring DC current is PMMC. PMMC instrument is also known as the RC Novel galvanometer, which is widely used for the measurement of DC current and voltage. So we know what is current measuring instrument, and it is PMMC, which we are going to learn today. So before learning the working principle of the PMMC instrument and what is the construction of PMMC instrument, we must know what is torque. We must know what is deflecting torque, what is controlling torque, what is force, what is Flamingo's left hand rule. So going to basic before understanding PMMC instrument, let's learn what is torque. Here we can see image where the torque is shown as a blue arrow and this is axis of rotation and here is the angle theta and the radius r is shown and this is rotational motion. Torque is a rotational equivalent of force. Now what is force? Going to very basic, force is like push or pull upon an object that cause a change in state of motion or a shape. But when it comes to rotational force, it is torque. So torque is equal to force cross perpendicular distance from its axis. We know torque is equal to force cross perpendicular distance. So, and the angle between the radius r and axis of rotation is theta. Now, we can understand the torque by bifurcating them into two parts like static torque and dynamic torque. Static torque is what? When the object is not rotating, it's known as a static torque. Like we have seen the bolt. So bolt is a not rotating. But how we fitting the torque? Okay. So it's a example of static torque, and here we can see the example of dynamic torque. Here is a motor shaft. Okay, here is bearing and shaft and slip ring assemblies. Here we can see. So when the object is already in motion, okay, it's already rotating when the motor is working, so the torque induced is known as a dynamic torque. So it's denoted as a Newton meter and the CGS unit is Dyne centimeter. So this is static torque and this is dynamic torque. Simply, when object is steady, the torque applied is steady torque. When the object is in rotation, and the torque applied is dynamic torque. Now let's understand what is deflecting torque. When current flows through the coil placed in a magnetic field, a mechanical force acts on both sides of the coil. This force causes coil to rotate, producing deflecting torque. Okay, force on the current carrying conductor. So this is known as a deflecting torque. Suppose there is a magnetic field which is in a one direction. So we place the coil in between the magnetic field and apply current to the coil. So due to that current, coil rotates, and due to that rotation, the torque is produced. Like we know the definition of torque. So this torque is known as a deflecting torque. So we can understand deflecting torque by F is equal to BIL, where F is equal to magnetic force, B is equal to flux density, I is equal to current through the coil, and L is equal to length of conductor in a magnetic field. Now let's understand that deflecting torque is directly proportional to the current through the coil. As the current through the coil load applies is high, the deflection torque is high. As the current in the coil is low, the deflecting torque is low. So there is a linear relationship between the torque and the current through the coil. Now, what is controlling torque? It is an opposite torque generated in the instrument to balance the deflecting torque and bring the pointer to a steady position, preventing it from the oscillating or going beyond the scale. Now, what is controlling torque? When we stop applying current in the coil, so it will create the torque in the opposite direction of deflecting torque. So, this is known as a controlling torque, which helps the pointer to stop and prevent the pointer to oscillate. So this is controlling torque is directly proportional to the angular deflection. Okay, T proportional to angular TC controlling torque is directly proportional to angular deflection. Here controlling torque is equal to C theta, and where C is the constant of the spring. Now let's understand Flamingo's left hand rule. Okay, so it's a very simple that if thumb, forefinger and middle finger are held mutually perpendicular, then the thumb indicates force in the conductor in the magnetic field, like here in a context of PMMC instrument. So here we understand that the thumb is denoted as a force experienced by the wire, and here the magnetic field, uniform magnetic field between the permanent magnets, and this is the current in the wire. So the force experienced by the wire is perpendicular. Now let's understand PMMC instrument. It's operate on the principle that current carrying conductor placed in a uniform magnetic field experience mechanical torque. We have seen in the definition of deflecting torque, it consists of a lightweight rectangular coil suspended in the field of permanent magnet. When DC flows through the coil, it experiences deflection torque, like it is proportional to the current, resulting in a pointer movement over calibrated scale. The PMMC instrument is an analog measuring device used to measure direct current It works on principle that current carrying conductor placed in a magnetic field experience torque. The current carrying conductor placed in a uniform magnetic field experience mechanical torque. This torque causes angular deflection of the coil, which is proportional to current passing through it. We have discussed this. Now, see, this is the permanent magnet. This is the moving coil in between the magnet. And when we apply current through the coil, there is an induce of deflection torque which moves this pointer. And when we stop applying the current, the opposite direction controlling torque is induced. Here we have used 12 bearings and here we have soft iron cores. Strong permanent magnet is made up of alnico or alcomax because of its high coercitivity. Then there is spiral springs. So this is the simple diagram of the PMMC instrument. Now let's understand each part of that. Moving coil. What is moving coil? A lightweight rectangular coil wound on an aluminum frame free to rotate. So this is moving coil. This is made up of aluminum. It's a rotating. Permanent magnet creates a strong and uniform magnetic field using curved pole pieces. These are permanent magnet. Soft iron core, cylindrical in a shape, placed inside the coil to increase flux density and uniformity. Control springs provides controlling torque and carry current to the moving coil. And pointer and scale. This pointer and scale shows the output of the PMMC instrument. The pointer moves over linear scale to indicate the value of current or voltage. The PMMC instrument is a precision device used primarily for measuring DC current, not AC. And AC we can see later how it works for AC also. And its construction has evolved with modern materials and design techniques to improve accuracy and reliability. Galvanometer or the arsenalometer is another name of PMMC instrument, and it's a core. The PMMC consists of a strong permanent magnet typically made up of high coercitivity material such as a alkano or alcomax, which ensures the stable and uniform magnetic field. A high coercive material is a type of magnet that is very strong and hard to demagnetize. It keeps its magnetism for a long time and it is used to make permanent magnets. Yes. So, there is a high alkano or alcomax is a high coercive material. Between the pole pieces of this magnet, a soft iron core is placed to reduce the reluctance of the magnetic path to maintain radial magnetic field, ensuring that the deflecting torque remains proportional to the current in the all positions. So here, what is the role of a soft iron core? Okay, the soft iron core used to reduce the reluctance of the magnetic path and to maintain its radial magnetic field, ensuring that the deflection torque remains proportional to the current. A rectangular moving coil wound with a fine insulated copper wire is mounted on a light-weighted aluminum former and suspended within the magnetic field during jewel bearing. Thus allows coil to rotate freely with the minimum friction. When current passes through the coil, it experiences a torque due to the interaction with the magnetic field, causing it to deflect. Attached to the coil is a pointer they move over linear calibrated scale indicating the magnitude of the current. Damping is provided by eddy currents generated in the aluminum former as it moves through the magnetic field, prevents oscillation and enabling the pointer to settle quickly. Now, we will see what is eddy current. Eddy current are tiny loops of electricity that forms inside metal when magnet moves nearby or magnetic field changes. They can cause the metal to heat up and they are like tiny electrical whirlpool inside the metal. So what happens here? Damping is provided by this tiny loops generated in the aluminum former as it moves through the magnetic field. Now it is preventing oscillations and enabling the pointer to settle quickly. The coil is controlled by two spiral springs made of phosphor bronze, which provide the necessary restoring torque and also serve as an electric conductor for current flow. Now, we have seen the spiral springs, okay, for controlling torque, okay, which provides necessary restoring torque and also serve as electric conductor for current flow. Recent developments have focused on improving the material quality, enhancing mechanical stability, and reducing errors due to temperature variation in external disturbance. Like in a PMMC, the disadvantages was the aging of the instrument. When PMMC is aging, magnet is aging. So due to some temperature difference, there could be error. So in but recent developments of the PMMC, though this time researchers have focused on improving the material quality. So, because of that, it enhanced the mechanical stability and error is minimized. These advancements make the PMMC instrument reliable and accurate tool for laboratories and industrial applications in DC measurement. Now, let's see advantages of PMMC instrument. No hysteresis loss. We all know this is this is for DC current measurement. So there is a magnetic reversers. DC current measurement, there is a no oscillations in the system. So there is a no hysteresis loss. So high torque to weight ratio. Due to that, it is quick and sensitive in deflection. Like small change, it will give output in. Now we can extend the range using this PMMC instrument by series resistor for ammeter and shunt resistor for voltmeter, and the power consumption is low for shunt resistor. It operates with minimum current like milliampere or microampere for uniform scale. Scale is linear, making readings easier and more accurate and high accuracy. So this is excellent for precise DC measurement. And we can have desired output by putting shunt series resistor through ammeter and voltmeter. What is disadvantage? Expensive construction because the cost of permanent magnet is high. Okay, so the overall cost of PMMC goes high. It's not suitable for AC measurement. Average torque in a AC is equal to 0, hence deflection is null. So there might be errors over time due to not suitable for AC measurement. Average torque in AC is equal to 0. Hence, the deflection of the system is null. Okay. So, when permanent magnet passes through a long time, so there is a loss of tension in a control springs. Due to some temperature variation, there might be error, and due to friction in the moving parts, there also could be error. So these are disadvantages of the PMMC coil. PMMC instrument is a reliable and accurate device used for a DC measurement. It operates on the principle of deflecting torque generated in a moving coil placed in a magnetic field. By integrating external components like shunt, series resistor, rectifier, amplifier, thermocouple, PMMC system can be adopted to measure current, voltage, resistance, and even some AC equivalent. The pointer deflection provides direct reading proportional to the current. So, if we place a shunt resistor for an ammeter extension, what it does, it bypasses the external excess current so that the full scale deflection current flows through the PMMC coil. And by putting the series resistor for a voltmeter extension, so what happens is the voltage drop. So due to that, limits the current to full scale when higher voltage is applied. So in this video, we have seen the construction of the PMMC instrument. This is known as a the Arsenal galvanometer, in which we have seen two permanent magnets, and also we have seen uniform magnetic field, the coil placed between the magnets, and how it generates deflecting torque, and how controlling torque is helpful in this PMMC instrument, and which materials are used, and how deflection scale is moving uh, and it's showing readings, and which materials are used, what is AD current. Also we have seen high coercive material, and also we have learned some basics like torque, Flamingo's left hand rule, and for more applications we have seen for ammeter and voltmeter how shunt and series resistor can be used. Also we have seen the static torque and dynamic torque, and what is current measuring instrument. And in the next lecture we will see other current measuring instrument, but the basic in all is PMMC instrument.